Hey students, in this video we'll be solving some of the most confusing mood questions from the year 2024, and this is the part 2 of the video. We're going to solve 5 more questions in this video. We solved first 5 questions in the previous video in the first part, so do consult it. I'll link it in the end. Calculate the volume of ammonia measured at room temperature and pressure, which forms when 1.12 grams of calcium oxide is heated with excess NH4Cl. Now, in this question, we have to find out the volume of ammonia. So, we will calculate the volume of ammonia. Volume of ammonia we need to find. We have been given the mass of calcium oxide. Mass of calcium oxide is given to us, which is 1.12 grams. To convert the mass into the volume, mass of one substance to the volume of the other substance, we will do 3 steps. In the first step, we will convert the mass of calcium oxide into the moles of calcium oxide. From the moles of calcium oxide, in step number 2, we'll find the moles of ammonia. And from the moles of ammonia, we'll find out the volume of ammonia in step number 3. These steps are called chemical footbridge, and they are used in many questions. Chemical footbridge. Let's start it. From the mass to moles, we will use the formula moles is equal to mass over molar mass. The mass is 1.12 and the molar mass of calcium oxide, CaO, the MR of calcium oxide, the calcium is 40 and oxygen is 16, total 56. So molar mass is 56, 1.12 divided by 56, and the answer is 0.02 moles. Now from the moles of calcium oxide, we'll find the moles of ammonia by taking the ratio. So we have to take the ratio from the equation. The equation for this question is like this. We have calcium oxide plus NH4Cl. This is an alkali, a base or alkali. When it reacts with the ammonium salt, which is NH4Cl, it will form calcium chloride plus water plus ammonia gas. So that's the equation. And for the balancing, we'll write it 2, 2. So as for the ratio, we have 1:2, 1:2. Here, we'll take the ratio between calcium oxide and ammonia. Calcium oxide is 1 and ammonia is 2 according to the equation. So 0.02 will give how much? It will be 0.02 multiplied by 2, and the number of moles of ammonia will be 0.04 moles. These are the moles of ammonia. Now we'll calculate the volume of the ammonia in step number 3 by using the formula moles is equal to volume over molar volume, which is going to be 24,000 in this case. The number of moles are 0.04 multiplied by 24,000 is equal to volume. We'll take it on the side. After multiplying, we'll get the answer 960. So this is the answer. I'll repeat. In the first part, we'll calculate the number of moles of calcium oxide or anything, any amount which will be given to you in the question. First, we'll convert it into the moles. From the moles of that substance, we'll calculate the moles of the second substance by taking the ratio. And from the moles of the second substance, we will find the volume or any amount of that substance by taking the formula, by using the formula. So in the first and last step, we'll use the formula, and in the middle step, we'll take the ratio from the equation. I hope this question is clear. Now we have the next question from the paper 41. We have the relative abundance of thallium here. We have the two isotopes of thallium, 203 and 205. They are present in the ratio 3:7. We have to find out the relative atomic mass of thallium, RAM. So to find out the RAM, we'll do for the first, we will add the two isotopes with each other. And how we will add the two isotopes? First, we will multiply the isotope's mass with its abundance. So the thallium 203 is in amount 3%, and the thallium 2.205 is in the amount 7, in the percentage 7. So we'll multiply this 203 with 3, its percentage, plus the other isotope, 205, will multiply it with 7. So basically, we are multiplying the mass of every isotope with its percentage. We'll add them together, divide by the total number of the percentage. So there is 3. One of the isotope is 3% and the other isotope is 7%. So 3 plus 7 gives 10. So we'll divide it by 10. 203 into 3. 203 into 3, it's 609 plus 205 multiplied by 7 divided by 10. And the answer is 204.4. Suggest why these two isotopes have identical chemical properties. As chemical properties depends upon the number of electrons present in the outer shell, and in isotopes, there are same number of electrons in the outer shell. So we'll write here that these two isotopes have identical properties due to same electronic configuration. Same electronic configuration. Next question. We have the crystal here, copper cobalt sulfate, hydrated cobalt sulfate, and we have to find out its the number of moles of water of crystallization, the value of X. So for that one, it's written in an experiment, 1.405 grams of the crystals is heated until all the water is given off. The mass of the salt is anhydrous. When we have the crystals mass is 1.405, and when they are heated, we are left with anhydrous salt, and its mass is also given, which is 0.75 grams. The molar mass of both are given to you. We have to calculate the number of moles of cobalt sulfate by using the formula mass over molar mass. Mass over molar mass. For the cobalt sulfate, the mass is given 1.405 for the mass of cobalt sulfate. Cobalt sulfate mass is 0.775. Well, divided by 155. 0.775 divided by 155. It's 0.005. Now we'll see the mass of water given off. What we'll do, we have the mass of the crystals. We'll minus the mass of the anhydrous salt from the crystals to get the mass of water. So the crystal's mass here is 1.405 minus the anhydrous salt is 0.775. We'll minus both of them to find out the mass of water. We have 1.405 minus 0.775, and the answer is 0.63. Now we'll find the number of moles by using the same formula. Moles is equal to mass over molar mass. Here, the mass of water is 0.63 divided by 18, which is the molar mass of water. 0.63 divided by 18, and the answer is 0.035. Now, to find out the value of X, we'll do the moles of water. The moles of water divided by the moles of salt, which is cobalt sulfate. So we have the moles of water 0.63 divided by the moles of salt 0.005. The moles of water here are 0.035. 0.035 divided by 0.005. And it is 7. So the number of moles are 7 here, and the formula of this crystal will be COSO4 cobalt sulfate dot 7H2O, like this. The next question is finding the empirical formula. To find the empirical formula, again, we have the percentage of carbon and hydrogen. Carbon ratio hydrogen will do. We have carbon 83.33. We'll divide it by 12. Hydrogen is 16.67. We'll divide it by 1. For hydrogen, we get 16.67. And for carbon, we get 83.33 divided by 12. It's 6.94. This is our step number 1. Now, in step number 2, we will divide them by the least number, which is 6.94. 6.94. Carbon will be 1, and hydrogen is 2.4. As you can see, we are not getting the whole number for hydrogen, so we'll multiply it with 2. When we multiply it with 2, carbon becomes 2, and hydrogen becomes 4.8. So with 2, we are not getting the answer. So 2.4 will multiply it with 3. With 3 also, if we multiply this with 3, we're getting the answer 7.2. So let's check it with 4. If we multiply this 2.4 with 4, we are getting, if we multiply it with 4, then we are getting the answer 9.6. So we have to multiply it with 5. If we multiply it with 5, we are getting the answer 12, which is the whole number. So basically, we have to multiply it with 5 to get 5 carbons and 12 hydrogen. So the empirical formula will be C5H12. To find out the molecular formula, we will multiply a number with the empirical formula, which is given in the question here, C2H5. So we'll multiply this C2H5 with the value of N. How do we find the N? To find the N, we will divide the molecular mass, which is 58. We'll divide it with the empirical formula mass. The empirical formula here is C2H5. We'll multiply 12 into 2 plus 1 into 5 to find out the mass of this empirical formula. So it's going to be 24 plus 5, 29. So 58 divided by 29, the answer is 2. So we'll multiply this empirical formula with 2. 2C2H5, and the answer is C4H10. That's the answer. That's the molecular formula. We have the last question here, which is iron oxide Fe2O3 in iron ore is converted to iron when it reacts with carbon monoxide. Calculate the percentage by mass of iron in iron oxide. The formula to find the percentage by mass of any substance, the formula is the mass of that substance in a compound, which is iron over here, the mass of iron in this compound divided by the MR of this compound. Now let's find out. There are 2 atoms of Fe. So we'll see the atomic mass of iron. Atomic mass of iron is 55, or basically 56. So we'll multiply this 56 with 2. And the answer is 112. So in the numerator, we'll put 112. And in the denominator, we put the molecular mass of iron oxide. So iron Fe2 is 112 plus oxygen 16 into 3. So 112, 16 multiplied by 3 is 48. So 112 plus 48. And this is 160. Now we'll put this 160 in the denominator. We'll multiply it with 100 to get the percentage. 112 divided by 160 multiplied by 100, and we get the answer 70%. So here the mass of iron is 70%. These are some of the most confusing questions from the year 2024. I'll link my first video at the end. You can check it out. Thank you.